continuing. So we have what's this supposed to mean? Let me just check. So this is basically a right circular cone of radius r and altitude h is circumscribed about a sphere of radius 5. So we ought to find the values of r and h if the volume of the cone is to be a minimum. So let's first draw. So this is our cone. It is circumscribed about a sphere. So a sphere is located inside. And then we have the radius, we have the height. In 2D, this is what it looks like. So this is gonna be our cone, and we have the sphere inside. Again, this is the height of the cone. What else? The radius is said to be 5, right? So let's just say this is the radius. So 5. Either way, from here to here, it's theoretically also 5, as well as here. So why did I mention that out of the blue? So let's imagine there's a triangle over here. So this distance is basically height minus 5. And this is pi. We're going to make use of special triangles here. So let me just show this portion. Copy, paste. So this portion is a similar triangle. Similar to what? This part. So essentially they are similar triangles. So let's try to orient. Okay. Essentially, angle theta is at the top. This is h minus 5, right? This measure, and this entire measure is just h. Here, that's just equal to 5 as well. So 5. How about this measure? So that's let's assume this is angle beta. It's not, I don't think we will be able to find the measure of this just yet. Let's see. The formula of a cone's volume is equal to 1/3 pi r squared h, right? I just capitalized. And before that, before deriving, I want to express h in terms of radius. So how do I do that? This measure is missing. So let's try to find that value. Let's say that's equal to x. Using the Pythagorean theorem, let's assume that x is equal to a. So a squared is equal to c squared minus b squared. C squared, c is h minus 5. B is 5. Let's not put a square root. These can cancel. And then we square root. There you go. So after that, let's apply ratio. Radius over height. Radius is equal to 5, right? So the height, it's also this one, since similar triangle. Technically, that is supposed to be a. So h squared, square root of h squared minus 10h. So if you want to express r in terms of h, we write this. And then, from there, we substitute that to the volume formula. So V is equal to 1/3 pi and then R. R squared H. Simplify, then we find the derivative, aka find dV over dH. Since with respect to H, our other variable is just H. We don't have a radius anymore. 25h squared 25 pi over 3 times h cubed over h squared minus 10h. So that's the volume. Now find dH over, find dV over dH. So 25 pi over 3. We apply quotient rule. So 3h squared minus h cubed times h minus 10. Twenty-five pi over 3. How do we simplify this? 3h raised to 4 minus 30h raised to 3 minus h raised to 4 plus 10h raised to 3. Okay. Now we equate it to 0. And I need more space. So we multiply both sides by 3 times h squared minus 10h then whole squared and 20 over 25 pi. So these could cancel. You multiply the same thing with the other side, but it doesn't make a difference. Anything times 0 is 0. So 0 is equal to, at this point, just copy this. And then, what can we do? Like terms. So 3h raised to 4 minus h raised to 4, that's going to be 2h raised to 4. And then minus 20h raised to 3. What's next? Chat, am I in the right path? Something doesn't look right. Oh, what's the derivative of h squared minus 10h? For h squared, that's going to be 2h. That's what I was missing. So this becomes 1h raised to 4. Okay. So h cubed h minus 20 is equal to 0. If you divide both sides by h cubed, what you have left is h minus 20 equal to 0. So h equal to 20. That is the height. Now you find the radius. So I think we can use this. So you just substitute h as 20. So r is equal to 5 times 20 divided by 20 squared minus 10 times 20. 100 divided by square root of 400 minus 200. Rationalize. So square root of 200 over 2. We can further simplify this, I believe. 5 times 10, 50, 50 times 4, 200. Okay. 5 squared, 2 squared times... No. 10 square root of 2 over 2. 5 square root of 2. That is the radius. Okay? I think that's it. We found the radius and height value that is supposed to constitute to a volume that's gonna be a minimum. So that's it. So all that just to solve this problem. All of that. Yep. As you can see, I already have solutions for the last two questions. I feel motivated to answer number 5, not number 6. If I'm gonna be honest with you, I don't like number 6. Story time. I did see a similar question to this in the final exam, but good thing it was multiple choice. So in case I got it wrong, which I most likely did, because I didn't know how to solve for it, I only got a deduction of 2 for that part. If it were a word problem wherein you had to actually solve for it, you had to show your solution, and the total points you can get is 10 points or 15, then it increases my likelihood to fail, which I didn't. Fortunately, I passed the course. So yeah, in a few weeks I'll be having integral. So yeah, I need to keep going. Okay, so number 5, you have to find two numbers whose product is 400. And if the sum of the square of the first number and the second number is at a minimum. Let me just continue. It was cut short. And second number is at a minimum. So two numbers whose product is 400, so I've already shown it here. xy is 400, and if the sum of the square of the first number is x, right? And second number is at a minimum. Minimum, let's say smallest, so it's denoted by capital S. So I think we can apply. No. This would be useful for later. So express x in terms of y, or express y in terms of x. And you find ds over dx. So that's basically going to be, S could be, if you want to express it only in terms of either x or y, I'm going to choose x. So x squared plus y is 400 over x, right? So 400 over x. Then we find the derivative. So 2x plus, let's rewrite this as 400 x raised to negative 1. So minus 400 x raised to negative 2 times 1, doesn't change anything. 2x minus 400 over x squared. Then we equate it to 0. So 2x cubed minus 400 is equal to 0. 2x cubed is equal to 400. X cubed is equal to 200. If we apply cube root on both sides, we have cube root 200. Or if you want to further simplify, sometimes you have to. It's 2 cube root of 25. So that is our x value. Now, we identify what y is. So how do we do that? Using xy is equal to 400, just substitute. So 2 square root 25 times y equal to 400. Divide both sides by x. So this appears to be our we can rationalize. Squared because what's inside has to be cubed so that we could bring 25 outside. So 200 cube root 25 squared divided by 25. Ah, okay. And then 548. 8 cube root yeah, 25 squared could be rewritten as 5 squared, or 5 cubed and then times 5. So this is 40 cube root of 5. That is equal to our y value. That's it. We found the two numbers whose product is 400, and if the sum of the square of the first number and the second number is at a minimum. That's it. Last question. So a car can travel along the road solid line at 54 kph, but it slows down to 36 kph in gravel. If the driver wants to minimize the drive time from A to D, when should they start crossing the into gravel? So let's have this illustration. So this is A, B, C, D. This is 250 meters. Okay, so in the sentence problem, not all details are given. We are provided with 250 meters, that is the distance CD, and we have 400 meters for the road. This part is the gravel. So let this be our X. So the full road in total is 650 meters. So you find the sum of 250 and 400. The time it takes to travel by full road is solid line at 54 kph, right? 54 kilometers per hour. We want meters per second. So 1,000 meters over 1 kilometer, 1 hour over 3,600 seconds. So this is equal to basically 15 meters per second. So that's the value here. And the time to minimize the drive time is equal to 400 minus x over 15 meters per second plus let's label this as b. So that's b squared plus x squared. Basically these two sides, the opposite and adjacent, since this one is the hypotenuse. Don't forget the square root. Over 10 meters per second. Where did we get 10 meters per second? So it says slows down to 36 kph in gravel, right? So this portion is the gravel part. So 36 kilometers per hour. Apply this treatment there. And it will equal to 10 meters per second. So we want to minimize, right? So this is the drive time on road AB, so from here to here. And this is the speed in meters per second on the road. This is the speed on gravel in meters per second, and this is the travel time from B to D. Since C squared is equal to B squared plus X squared, right? Based on the Pythagorean theorem, it's this. So what we do now is further simplify. So 400x minus over 15 x squared plus 250 squared divided by 10. 400 over 15 minus x over 15 plus x squared plus 250 squared times 1 over 10. Now we find dt over dx. So suppose we apply quotient rule. 15 times negative 1 minus 400 minus x times 0 divided by 15 squared, 225. Okay. 1 over 10, 1 over 2, x squared plus 250 squared raised to negative 1/2 times 2x. Okay. Then we equate it to 0. We can further simplify, by the way. Negative 1 over 15 plus x over 10 square root of x squared plus 250 squared. Then multiply both sides by 30. Square root of x squared plus 250 squared. So 0 is equal to negative 2 3x, and then transpose to the other side, plus plus. You erase both sides so that the radical sign would be removed. And then what's next? Distributive property. Five x squared is equal to 4 times 250 squared. So it's going to be like that, and x is going to be 100 square root 5. This is the rest of the solution. So this is where we finished, and that's basically it for this question. So that's it. Thanks for watching.